Hi Year 11, today what we are looking at is the product rule of probability. So we're going to use the multiplication law P of A bracket A and B equals the probability of A times the probability of B for independent events A and B, and recognise the symmetry of independence in simple probability situations. So tossing two coins and rolling two dice are examples of multi-stage experiments where two outcomes happen together. The sample space becomes more complicated, so to list all possible outcomes, we use tables and tree diagrams. Firstly, we're going to look at this first example where we're going to find the sample space and the probability of each outcome for tossing two coins by drawing a tree diagram. Now with our tree diagram, our first two branches is when we toss our first coin, so it's our coin number 1. So we will have our outcomes to be that we can either get a head or a tail. Now, because we have a head or a tail, we have a total of 2 outcomes, and so our probability of tossing a head on our first coin is a half, and our probability of tossing a tail on our first coin is also a half. So this is our first coin. We then have our second coin. So with our second coin, once we've tossed a head or a tail, we can either get a head or a tail on either for the second coin, and the probability of getting a head or a tail stays at 1/2. So that is how we draw our tree diagram for tossing two coins. We then have our outcomes, and so our outcomes form our sample space. With our tree diagram, we start at the very start over here, and then we make our way along the branches. So our first outcome would be HH, so 2 heads. Then we have HT, so a head and a tail. Then we have TH, so a tail and a head. And then we have TT, which is a tail and a tail. We then find the probability of our outcomes by multiplying our branches of our tree diagram. So the probability of HH will be a half times a half. The probability of a H and a tail is the right way that I should write my probability now that we know this notation. So probability of a H and H, probability of a H and a tail is a half times a half also. So these are quarters. The probability of a tail and a head is a half times a half, which is also equal to a quarter, and the probability of a tail and a tail is equal to a half times a half, which equals 1/4. Now, our second example is to find the sample space and the probability of each outcome for rolling 2 dice and calculating their sum by constructing a table. So we have our table here. We can fill our sample space by adding our columns and rows. So the first one here is 1 + 1, which is 2. Then if we go across, 1 + 2, 3, 1 + 3, 4, 1 + 4, 5, 1 + 5, 6, 1 + 6, 7. Next row, 1 + 2 is 3, 2 + 2 is 4, 3 + 2 is 5, 4 + 2 is 6, 5 + 2 is 7, 6 + 2 is 8, 1 + 3 is 4, 2 + 3 is 5, 3 + 3 is 6, 4 + 3 is 7, 5 + 3 is 8, and 6 + 3 is 9. Next row, 1 + 4 is 5, 2 + 4 is 6, 3 + 4 is 7, 4 + 4 is 8, 5 + 4 is 9, and 6 + 4 is 10. We then have 1 + 5 is 6, 2 + 5 is 7, 3 + 5 is 8, 4 + 5 is 9, 5 + 5 is 10, 6 + 5 is 11, and our last row, 1 + 6 is 7, 2 + 6 is 8, 3 + 6 is 9, 4 + 6 is 10, 5 + 6 is 11, and 6 + 6 is 12. Now we could write out the sample space will be really huge, so that's why we do a table to show our sample space. But we can also work out the probability of any of these events happening. So say we did the probability of a 1 and a 1. This would be the sum of 2 over, this would just be that it occurs 1 out of 36 times. Okay. Finally, we have our product rule for independent events. So if A and B are independent events, the A occurring does not affect the probability of B occurring. The probability of both occurring is the product of their probabilities. So what we have is this formula, probability of A and B equals the probability of A times the probability of B. Now this formula is on your reference sheet, so if you can pull your reference sheets out, we're going to annotate that now. And what we have is our intersection symbol here as well. Okay, so going to our reference sheet on page 2. So in our probability section, we now have seen this formula here, and it's our product rule. For independent events. Might need to move this up a bit. Cool. Alrighty, back to our examples. So the first example is find the probability of rolling a double 4 on a dice. So that is the probability of finding a 4. Oh my gosh, this pen. Sorry guys. So it's the probability of finding a 4 and a 4. So the probability of finding a 4 times the probability of finding a 4 is equal to, well, the probability of finding a 4 is 1 over 6 times the probability of rolling a 4 is 1 over 6. So when we multiply these together, we get 1 over 36. For our next example, we have the probability that a darts player hits a bullseye on a dartboard is 8 out of 11. Find the probability that the darts player will hit the target twice. So we have the probability that it hits the dartboard is 8 over 11. We want to hit the target twice. So we're going to have the probability of H and H, so hit and hit, is equal to the probability of hit times the probability of a hit, which equals 8 over 11 times 8 over 11, which equals, well, I don't have enough space there, do I? Which equals 64 over 121, and that is in its simplest form. Now we have to work out the probability that the darts player will miss the target twice. So we're going to use M for miss. We can write that, let M equal miss. So we'll have the probability of M is equal to 1 minus the probability that it hits. So, because these are complementary events. So it'll be 1 minus 8 over 11, which is equal to 3 over 11. So then the probability that we get a miss and a miss is equal to the probability of a miss times the probability of a miss, which equals 3 over 11 times 3 over 11, which equals 9 over 121. Alrighty guys, so you are doing evens for this question, for this exercise 705, except for question 14, you're actually going to do question 15.